Good day, everyone. You are welcome to the second section of integral calculus. Here, we are going to take a look at some special form of integral. Special form of integral. Now, let us take a look at the first one. A, the integral of the form integral of ax plus b dx. Now, when we are given this type of integral, what we'll do is we say let u represent what is inside this bracket, ax plus b. Then the next thing, we differentiate u with respect to x. Say du dx is equal to ax. When we differentiate ax, it will give us a. When we differentiate b, it's 0 because it is a constant. Then from here, if du dx is equal to a, then when we invert it, we have the x du. Then we also invert this a. A is on top of 1 before it will turn to 1 over a. Therefore, the integral ax plus b dx will become, this one has turned to u, the x will be du, the x will be the x du multiplied by du. You know, when this du cancel this du, we still have our dx back here. So we have not done anything wrong here. Then we now have integral of u dot dx du is equal to 1 over a, then du. 1 over a is a constant, we'll bring it out, we have 1 over a integral of u du. Can you see, we have succeeded in changing everything to u function. So let us take a look at some work example. Let's take a look at some work examples. Number one, supposing you are given the integral of 2x plus 3 raised to power 5 dx. Now we say let u be equal to 2x plus 3. Then we now differentiate u with respect to x. We have du dx is equal to, when we differentiate 2x, it will give us 2. When we differentiate 3, being constant, it's 0, we throw it away. Then we invert this, we have the x du will be equal to what? Remember, 2 is standing on top of 1. When we invert it, it turns to 1 over 2. Then this one, integral of 2x plus 3 raised to power 5 dx becomes, then we have 2x plus 1 will be u, then raised to power 5. Our dx will be dx du multiply du. As I've said earlier, when this one cancels this out, we still have our dx back. We have not done anything wrong. Then from here, we have integral of u raised to power 5. Dx du is 1 over 2 du. Then when we remove this constant and bring it out, we have 1 over 2 integral of u raised to power 5 du. Now it's now easy for us to integrate this one. This will be 1 over 2. When we integrate this one, this will be u raised to power 6 over 6 plus the constant of integration, and this will be 1 over 12 u raised to power 6 plus the constant of integration. Then we now replace our u, which is equal to 2x plus 3. Therefore, the integral becomes 1 over 12 2x plus 3 raised to power 6. Now, this is the former method of doing it. Assuming this one appears in objective, so you don't need to follow all this procedure. There is a shortcut for this type. Now, let me show you the shortcut. The shortcut for this. So we're giving 2x plus 3 raised to power 5 to integrate. What you will do is you will differentiate, you will write the function itself 2x plus 3. You will differentiate what is inside. When you differentiate, this one is 2. You use it to divide it. Then you add 1 to the power, making 6. Then you divide it by the new power. This will be 1 over 12 2x plus 3 raised to power 6. This is the shortcut for this. Now let's take a look at another example. Example 2 here, we are given the integral of 3dx over 4x minus 1 raised to power 3. Now follow the same procedure. Say let u be equal to 4x minus 1, then du dx is equal to, when we differentiate this one, this will be 4. Then when we turn it upside down, we have the x du is equal to 1 over 4. Then this integral 3 dx over 4x minus 1 raised to power 3 will be equal to integral of, this is 3 over, the whole of this is u raised to power 3. Our dx is dx du multiply du. Then from here, this 3 is a constant. Okay, now let us substitute this value. This will be integral of 3 over u raised to power 3. Dx du is equal to 1 over 4. Then we have du here. Then we have this 3, we'll bring it out because it's a constant value. Then this 4 will come out as well. We now have 1 over u raised to power 3 du. Now we have 3 over 4 integral of 1 over u raised to power 3 du. Now we now integrate this. We have 3 over 4 integral of 1 over u raised to power 3 can be written as u raised to power minus 3 du. Now it's now easier for us to integrate this. Then we now have 3 over 4. When we integrate this one, this will be u. We add 1 to the power to be minus 2. We divide it by the new power, which is minus 2. Then we add the constant of integration. Then this will be 3 over 4 times minus 2. This will be minus 8 u raised to power 2 minus 2 plus c. When we remove this minus from the reciprocal, from the power, then we take the reciprocal. We have minus 3 over 8 times 1 over u raised to power 2 plus c, and this will be minus 3 over 8 u raised to power 2 plus c, and this can be written as minus 3 over 8 into our u. What is our u? Here, our u is 4x minus 1. What is our u? Our u is 4x minus 1 raised to power 2, then plus constant of integration. Now, let us take a look at the third example here. We are given the integral of cos 7x dx. You are to integrate this. You follow the same procedure. You say let u be equal to 7x. Then du dx is going to be, when we differentiate 7x to give you 7, then let us turn it upside down. We have the x over du is equal to 1 over 7. Then the integral cos 7x dx will become cos 7x is u, then the x can be written as the x over du times du. Then this will be equal to integral of cos u. The x du is 1 over 7 du. Then this will be 1 over 7 is a constant value. Then we'll bring it out. Integral of cos u du. Then what next? What we'll do here is we integrate cos u. Then we have 1 over 7. When we integrate cos u, it will give us sine u. Then we put our constant of integration. Then we now replace u, which is equal to 7x. Then we now have this one as 1 over 7 sine 7x plus c. Then let us look at, there is a shortcut for these two. The shortcut for this is we are to integrate cos 7x, the x. Now what you do is you differentiate 7x, it will be 7, then you use it to divide the integral of cos. The integral of cos is sine, then 7x plus the constant of integration. So this is the shortcut for this. Then let us take another example here. Number 4, we have the integral of sine 1 over 2x dx. We say let u be equal to 1 over 2x. Then when we differentiate u with respect to x, it's going to be 1 over 2. Then when we turn it upside down, we have the x, the u, it's going to be 2 over 1, which is 2. Then the integral sine 1 over 2x, the x will become sine u. The x is the x du times du. Then we have integral of sine u. The x du is 2, then du. Then we'll bring these two outside because it is a constant value. Then sine u du. Now we now integrate sine u. When we integrate sine u, it will give us minus cos u. We bring the minus here, then plus the constant of integration. Then we now replace u, which is equal to 1 over 2x. Therefore, our integration is equal to minus 2 cos 1 over 2x plus c. Then let's take a look at the 5th question here. Number 5. We're given the integral of exponential minus 5x plus 2 dx. Now we follow the same procedure. We say let u be equal to minus 5x plus 2. Then we differentiate u with respect to x. When we differentiate minus 5x, it will give us minus 5. Remember, when we differentiate 2, which is a constant, it's 0. So we throw it away. Then we now have integral of exponential minus 5x plus 2 dx will become integral of exponential u. The x is dx du times du. And this will be equal to integral of exponential u. The x du here is minus 5. Sorry, we did not invert it here. From here, the x du, when we invert it here, it will be minus 1 over 5. Then this will be minus 1 over 5. Then du. Then we remove this one and bring it out. This will be minus 1 over 5 integral of exponential u du. Now, when we integrate exponential u, it will still give us exponential u. Then we introduce our constant of integration. Then we now replace our u which is equal to minus 5x plus 2. Then we now have minus 1 over 5 exponential minus 5x plus 2 as our integration. Now, there is also a shortcut for this. Now, what is the shortcut? The shortcut is that we have to integrate exponential minus 5x plus 2. Now, what you do is that you differentiate minus 5x plus 2. When you differentiate minus 5x plus 2, it will give us minus 5. Then we use it to divide the integral of exponent. The integral of exponent is still its value back, then which is exponent minus, which is equal to exponent raised to power minus 5x plus 2. Then we introduce our constant. Thank you very much. I'll be expecting the video of section 3 soon.